Hi, my name is Stewart Lynch, and in this video I'd like to introduce you to a new ColorView modifier that will allow you to mix two color views together to produce a third mixed color view. We're going to be using this to create an app that will generate an array of color swatches for you based on that mixed color. I love getting your feedback, so if you enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you ring the bell to enable notifications and get notified whenever a new video is released. And if you want to support my work, you can buy me a coffee. A link is in the description. There is a starter project for this video, and you can download it from the link in the description. There are two branches, so make sure that you download the starter branch for this project, as it has the starter resources. The completed branch contains the completed source code for the video. You can just download and expand the zipped archive. The project does require Xcode 16, and at the time of this recording, I'm running beta 4. The starter project is basically a new project, except that I've included some color extensions that will allow us to display the RGB and hex values of a color that we create. Well, I'm not going to go into details of this code, but feel free to explore on your own. I include these in all of my cross-platform projects where I want to display either an RGB or hex value in my code. And the most recent one is my Mesh Gradient Creator app and the video that I created on Mesh Gradients. So in this video, I want to introduce you to the Mix Color modifier introduced in iOS 18 for SwiftUI color views. That's going to let us to blend two color views together. It's a very simple modifier, so I thought that I'd take the opportunity to build a practical use case for that modifier. Now, oftentimes when creating an app or designing a website, you need to develop a color scheme for your app. So what I want to do in this video is to create a way to generate a range of different colors. We'll use the new mix modifier and then allow you to create a range of different iterations on that particular color, and then select and choose a RGB or hex value that you might want to use in your own application. So we'll have two color pickers and another color view in the middle that is a mix of the two colors on either side. When I adjust the slider, it adjusts the percentage of each color used in the mix. If you pick different colors, you'll see that the mix changes accordingly. Now below that is my swatch creator that allows you to create from 3 to 11 different shade variants on that mixed color. And then when you tap on a swatch, you're presented with a hex and RGB values for the view. And that'll allow you then to generate a range of colors that you might want to use in your project. So let's get started. Let's replace the content and the body with a navigation stack. And inside there, we'll create a V stack. And I'm going to add a spacer. We'll be adding the content above that, so it will push everything up to the top. Then I'll apply some padding to the V stack. And then I'll apply a navigation title of ColorMixer. Now the mix modifier will allow us to mix two different SwiftUI color views together to get a third color view. So what I want to do then is to create two state properties for the colors that we will be changing by way of a color picker. So the first one I'm going to call color1, the state property, and I'll assign it a default value of red. Then I'll create a second state property called color2 that's going to be another color that we'll initialize as blue. The mix modifier, as you'll see, will mix both of those colors, but we'll have to apply a fraction, which is a double value between 0 and 1 that will determine how much of each color is used. So I'm going to create another state property called fraction as a double and initialize it as 0.5. So that our mix initially will be a perfect blend of both colors. Now the mix or blended color is going to be dependent on those three variables, and it'll change anytime we change any one of them. So I'll create a computed property that I'm going to call mix color that itself is going to be a color view. And then to get the mix color, we start with color1, and then we apply the mix modifier. And when you do that, you see that there are two initializers. So I'm going to choose the first one, and I'll explain the second one in a minute. And then the color that we're going to be mixing with color1 will be color2. And the fraction will be our fraction. And that will be the fraction applied to the second color. So in our case of 0.5, it means that it will be 0.5 left for the color 1 to get that perfect blend. So if the fraction, for example, were 0.75, it'll mean that the color 2 will have 3/4 of the color in the mix, whereas color 1 will only have 1/4. So in the view then, above the spacer, let's create an H stack with an alignment of bottom. And it's in here that I want to create each of those 3 color views. So I'll start with color 1, and then I'll apply a frame with a width and height of 100. And I'll also apply a clip shape of a rect with a corner radius of 10. Then I can just copy and paste this 2 more times and change color 1 to mix color and color 2 respectively. So you can see that the mixed color is purple, which is what you get when you mix red and blue together in equal portions. If I change the second color to yellow, you'll see that the mixed color is orange. Let's change it back to blue. If I change the color to 0.75, you see it gets closer to the blue color. If I change it to 0.25, it gets closer to red. Let's return to 0.5. Now what I want to do is to allow the users to make those choices. So for each color, I'm going to use a color picker, and for the fraction, I'll use a slider. So first, let's enclose color 1 view and its modifiers in a V stack. And then above this, we'll create a color picker and use the string color 1 for the label, and the selection is bound to the color 1 itself. Now I don't actually want to see this string color 1 as the label, so you might think you might just want to use an empty string. However, that doesn't work well with accessibility and screen readers, so instead apply a label is hidden modifier. And then repeat this for color 2. Now, as the first item in the VStack, I want to create a slider that's going to allow me to choose a double value between 0 and 1. And since this is the default range for a slider, we don't have to define the range, but we can choose the value label, minimum value label, and maximum value label initializer. So the value is going to be bound to the fraction. For the label, we'll use a text view with the string fraction. Now this isn't going to be displayed, but it's useful for screen readers. For the minimum value label, I'm just going to provide another text view using the string 0. And for the maximum value label, another text view using the string 1. So I can test now and see that we can pick a color, and our mixing is going to change. And we can also move the slider to see the effect. Well, I want more information though. Over each color, I want to display what fraction of that color is being used. So on the color 1 view, I'm going to create an overlay. And inside the overlay, I'm going to create a text view that's going to display not the fraction, but 1 minus the fraction, because that's the one on the left. And for the format, I'm going to choose a number format and specify a precision. And that precision is going to be a fraction length in a closed range of 0 to 2, meaning we'll only maximize at 2 decimal places. The second color is almost exactly the same, except that we're going to not use 1 minus fraction, rather just the fraction itself. And then the last thing I want to do in this section is display the corresponding hex and RGB values of each color that is used in the color view. And I want to display that directly below each color. Now the math here can get quite complicated, and to be honest, I don't even remember where I got the information from. So I've included the extension for this in the starter project in the Color Plus Extensions file, and it's called Color Strings, and it derives its value using the functions in the extension. This computed property here will display a string over 2 lines, and the first is a hex value for the color, and the second is the RGB string. So in the VStack, for color 1 below the overlay, you can create a text view using the color 1's color strings property. And then I'm going to apply a font using a system size of 10. And I want it to be centered, so I'll use a multi-line text alignment and apply center. And then I'll apply the same to color 2, just changing the color to color 2. For the mixed color view, I'll first need to embed the mixed color in a VStack. And then I can apply that same text view, changing it to a mixed color. As we change the colors and move the slider, you see the values change. I do want to go back to the mix modifier now though. If I right-click on the modifier to bring up Quick Help, I can see that I can provide an in argument that by default displays a color in what is known as a perceptual gradient color space. It's an enum case. And that's what you see now, as that's the default. It's the color space used to mix the colors. So if I add it back and add an in property with that perceptual case here, nothing's going to change. However, if I change it to the other enum option, which is device, it gives me a deeper shade of purple. And to be honest with you, I'm not sure what this really means. I'm not a designer, so I'm going to leave it at the default. It might mean that if the color is set to device, it'll look differently on different devices, if that's the choice that was made. Now, before I move on to the next part, let me just rename this content view to one that's called ColorMixer View. What I want to do now, below these 3 color views, is create a slider that's going to allow me to pick between 3 and 11 iterations of our mixed color. And the choice will have to be an odd number, because if I chose 3, it'll display the mixed color view in the center of the H stack, and then on the right and the left of that color view will be another views mixed evenly with either black, so a fraction of 0.5 on the right, and another color view mixed with white on the left, again using a fraction of 0.5. So if I chose, for example, 5 then, for my slider iterations, then on either side of the mixed color will be 2 color views, but the fraction of each will be 1/3 for the first one on each side, and then 2/3 on the second one. If I chose 7 then, there will be 3 on either side. So each fraction will be 1/4, increasing by 1/4 as you move away from the base mixed color. So 1/4 to 1/2 to 3/4. So getting progressively either darker or lighter depending on which direction you move. So in the ColorMixer view then, I'm going to add a new view that I'm going to pass in the current mixed color to. So I'm going to call that view ShaderView, and I'll pass in mixed color. Of course, that view doesn't exist yet, so let's do that. I'm going to create a new Swift file from the template and choose a SwiftUI view, and I'm going to call it ShaderView. And then I'll need that single property as a let called mixed color that is of type mixed color that we'll receive from our calling view. Then to stop the preview from complaining, I'm going to create a color, just like color cyan. Next, let's replace the body content with a VStack. Now there's no need to add any padding to this VStack because this view will be inside the ColorMixer View's VStack, and that already has padding applied. And it's above the spacer, so it will appear right below the other 3 ColorMixer views. Now our slider is going to have to know how many iterations we want. So let's create a state property for that I'm going to call total iterations, and it'll be initialized with a value of 3.0. To create the slider then, I'm going to choose a slider. So let me choose this initializer here and just remove what I don't need. I won't need that editing change, but I will need steps, and that's not here yet. So for the value, it's bound to total iterations. The range is going to be a closed range from 3 up to and including 11. Here's where I need to add the steps argument, because I only want odd numbers between 3 and 11, so that'll be a steps of 2. And then I can hit return on the label to get the trailing closures to complete this slider. For the label, for screen readers, I'll apply a text view with the string iterations. For the minimum value label, I'm going to display an image using a system image with the string 3.circle.fill. For the maximum value label, it's going to be another image using a system image, but this time it'll be 11.circle.fill, the maximum of that range. And I don't need this editing change, so I can remove it. And it looks like I made a mistake on my closed range. It's not valid. It should be an 11, not a 1. So below the slider, I'm going to create another image view displaying a system image using the current int value of the total iterations using a string interpolation with circle.fill. So let's apply some styling to that VStack now with a foreground style of that mixed color. And I'm going to increase the size of those images by applying an image scale of large. So it's below here, though, that I want to display an HStack that's going to contain a number of color views evenly spaced out with the correct mixing with either white or black. Let's just select and place a color view here for now. So we'll use a for each loop with the open range from 0 up to, but not including the total iterations. So for each, 0 up to, less than, but since the n has to be an int, we'll need to convert the total iterations to an int. And then we'll need to specify that the ID is self. And this will provide us with an index that we can use to determine what side of the color view we're on, whether we're on the left or the right side, so that we can mix it with either white or black in the correct fraction. For now, though, just to get it working, let's just present the mixed color and set the frame height on the HStack to 100. Now, as you move the slider, you see that specific number of views are generated. And if we switch back to the ColorMixer view, you can see it's working from there as well. Well, only the middle one of those colors in the HStack should be that full mix color. The remaining one should be mixed with either white or black, and progressively more as you move away from the center, which is the mixed color. So more black as you move to the right, and more white if you move to the left. So that means we're going to have to create a color view and pass in the color, the total iterations, and the current index, and then perform some calculation on that so that we can get the correct fraction and know if we need to mix with either white or black depending on what side of center we're on. So instead of presenting the mixed color in our HStack, let's create a new view that we can call ColorView that'll accept all three of those values. So let's create a new file from template, and it's going to be a SwiftUI file, and we'll call it ColorView. Inside the view then, above the body, let's create those three properties that we can pass in, namely the mixed color, which is a color, the index, which is an int, and total iterations, which I'll pass in as an int, even though it's a double currently. Then to stop the preview from complaining, let's pass in some sample values. So for example, a mixed color, color of teal. For index, we'll choose 0. And for the total iterations, let's choose 5. So this will be the first one in those 5 iterations. And I'll set a frame and width with a height of 100. Now what we need to do is to determine where the middle is and if the index is on the left or right side of center. Let's create an enum called position, and it's going to have 3 cases: left, center, and right. And that's going to make it easier for us to read our code. So first then, we'll create a computed property for position that will be one of these cases. First, I can determine the middle by dividing the total iterations by 2. Now, since total iterations is an int, when we divide by 2, it'll always truncate to the one less than the actual middle. But that's okay because our start index is at 0. So if the index is less than middle, we can return left. Else, if the index is equal to the middle, we'll return center. Else, for the remaining case, then we'll return right. Next, we'll need to determine the fraction value that we'll need to use for each of the mixes. And we can determine this by letting a denominator be equal to the total iterations divided by 2. But we'll need this to be a double, so we'll convert the total iterations to a double. And then we'll add 0.5. So this will be the denominator of our fraction. So we're going to return 1.0 divided by the denominator. So a half, a third, a quarter, and so on. So this will be used for the view or the color view on either side of the mixed color. But as we progress further out, we'll need to apply more of this particular color. So rather than wasting your time with the math, let me just give that to you. The fraction is going to be a double. And if the position is going to be equal to the left, we're going to return 1 minus double the index plus 1 times the fraction value. Else, we're going to return 1 minus double the total iterations minus the index times the fraction value. And that's all we need now. So if the position is equal to center, we'll simply return the mixed color. Otherwise, we're going to return the mixed color mixed with, if the position is on the left, we're going to return white. If the position is on the right, which is the other alternative, we're going to return black. And it's going to be by that fraction. So we can return to ShaderView now and replace our placeholder mixed color with that color view, passing in our 3 properties. And we'll need to make sure that we convert the total iterations to an int. If you return to the ColorMixer view now, then you'll see that when we use the slider, it'll display that number of iterations shaded. And if we change the color being mixed, the shades will update as well. There's just one more thing that we want to do. When I tap on one of those shades, I want that shade to display a border around it, and I want the corresponding hex and RGB values displayed below it. So in the shader view, let's create 2 new state properties that we can use. For the first one, we'll call it color strings, and we'll initialize it as an empty string. Then when we tap on one of the swatches, we'll replace that string with the corresponding color strings for the color using our color extensions variable. The second will be an optional int called selectedIndex, and that will be set whenever we tap on one of the swatches, and we're going to use that to create a border around the selected swatch. The action that will populate both of these values will be done in the tap gesture on our color view, so we'll need to pass them into that view. So let's add those 2 arguments at the call site in our shader view. We'll also have to make sure that these are passed in as bindings, so we'll add that $sign. Then in the color view, let's add those bindings to accept them. A binding for color strings, which is a string, and a binding for the selected index, which is an int, an optional int. Then to stop the preview from complaining, we can use the new previewable macro introduced in iOS 18 to assign values as state properties that we can use in our preview. So for example, a previewable state property for color strings, that'll be an empty string, and a previewable state property for selected index, that will be an optional int. And then we can use those in our color view. Next, we can create an on-tap gesture for the mix color. So first though, let's just cut out this if-else clause and turn this into a computed property that we can call adjusted color. And then we can use that adjusted color then as a single view inside the viewer itself and create a single on-tap gesture. And then for the gesture's action, then we can simply assign the adjusted colors color strings to the bound color strings, and also assign the index to the selected index. So this will now get passed back up to ShaderView, where we can use them. So in ShaderView, below the H stack, create a text view and use those color strings. And then we'll set the font to title and apply a multi-text alignment of center to center that string. Then within the for each loop of our color view, we can apply a border if the selected index is equal to index and make it gray. Otherwise, we'll make it clear. And we'll set a width of 4. And then the one remaining thing that we need to do is that every time we either change the mix color or the iteration slider, we'll need to reset the selected index to nil and the color strings back to an empty string. So we'll create an on change of for total iterations. We don't need the old or the new value. Anytime it changes, we'll simply set the selected index to nil and color strings back to an empty string. So for the same thing then, we'll just copy this and paste it in and change the on change that's watching to a mix color. Now to test this, I can go all the way back to our root ColorMixer view. And as I tap on the swatch, I see the gray border and the color strings are displayed. As soon as I adjust the slider, the strings disappear, as does the border, until I tap on another one. Similarly, I can update my mixer by choosing a different color or adjusting the fraction to change my swatch palette. And until I select one of the swatches, there's no gray border or color string. Well, that's it for this video, and I hope that you've learned something new that you can use in your projects going forward. If you've enjoyed this video, please give it a thumbs up and leave me a comment below. Be sure to subscribe to my channel and enable notifications so that you're made aware of new videos that I release. And you can also download my free channel listing app to be able to search for and find content from any one of my over 300 Swift and SwiftUI related videos. Thanks so much for watching.